Alright then guys, now that we have reached a new section of this course, I want to go through some important files inside a directory because every single file in here is actually pretty important. But before we continue on, I forgot to activate our Visual Studio Code Create Icons. So let's do that real quick because I want to see my folder icons right in front of the greater than sign. If you're on a Windows, go to File, Preferences, or if you're on a Mac, hit Shift-Command-P. Now right here, let's write down File Icon Theme. Let's open it. And instead of disabling our file icons, let's choose VS Code Create Icons. Alright, this is what I'm looking for. If it does not work for you, you could also go to the Help navigation item, write down File Icon Theme, and look, this is where you could find it. Alright, we're ready to kick off. If we look at our application, you might wonder where the model, view, and controller folders are. And to be honest, I was wondering the same exact thing when I started working with Laravel. I want to show you on a basic level how this application is built up. And during this course, you'll get to know the ins and outs of every little file inside of our directory. To be honest, there isn't a clear model, view, controller directory where we could create small components and use them within classes. The folder names are a little bit different. But don't get me wrong, it's still an MVC based framework. By default, the model classes are stored inside the app directory, right here, where you can find a models directory, so let's click on it. And by default, there's always a user.php. So let's open it. You might wonder what the user.php file is because we've never created it. And you're right, because Laravel will auto add a user.php file. Later on, when working with databases and models, you'll get a better understanding of this. The models that we create right here can be used in our controllers to interact with the database. Now for the controllers, you need to be in the same directory, but instead of the models directory, let's open HTTP. And right here, you can find the controllers directory. Let's click on it. You can see this as the place where you are going to organize the behavior of your application. So we're basically going to create some kind of model that we're going to use inside a controller in order to retrieve information from the database. And then we're going to pull that data in the right location of the view, which we're running in the controller. If we open our controller.php file, you can see that our class is extending the base controller. And our base controller is basically an abstract class called controller, which we honestly won't touch. But we can use command click, so let's click on it, and right here you can see the base controller that we're using. One thing is good to keep in mind is that, well, let's actually close off the controller. Let's open our main controller, and this controller that is extending the base controller is basically the file that our new files are going to extend. So if we're going to make a usage controller, we need to extend this controller file, and instead of saying controller, let's say class user controller extends the default controller. But let me go back for now because we won't do it in this video. Now in order to see your views, you need to open the resource directory right here, where you will find the CSS, JavaScript and views. Now let's open the views directory. And in here you see a welcome.blade.php file. What are other important files in here? Well, directories. We have our database, which I actually don't want to talk about right now because I want to make an entire section dedicated to the database. We have our routes directory, so let's see right here, which has an API.php, channels.php, console, and web. Now the API file is basically the location where you register API returns for our application. The channels file is where we register all the event broadcasting channels. The console.php is the location where we define console commands. Well, the most important one is the web.php, so let's open it. And well, this is the place where we are going to register routes, which we will do in the next section. Now, if you want to import products, you basically need to place them inside the storage directory. So let's say that you have a .csv file. Well, you basically need to start them right here. You can also find your logs back here. Right now it's empty because we haven't done anything. but I'll cover this later on as well. I want to talk about the .env file since it's a pretty important file. Now, env stands for environment, and this is the place where you put all of our environment setups. How this works is, well, you basically need to create an environment variable, what we have right here, so app_name, and we need to set it equal to a value. And as you can see, there are lots of predefined environment variables in here. Even if we scroll down, you can see a lot of them. You have your database connection, you have your drivers, you have the Redis host, and way more, the app URL, the app key, the app env, and the app name. Everything about the server that is running in the project and many different values for different servers are set up right here. And in some kind of way, you can see these as constants. A constant represents unique memory locations, and an environment variable is a variable that is set outside of the program. What I would like to show you right now is how we could use the environment variables. Just bear with me and follow along. Now, if we scroll up, let me close off the vendor directory. Let's open our routes and let's open the web.php. Right here, you can see that we're referring to a specific view called welcome. What we could do is change the return value. So instead of saying return view, let's delete that. And right here, let's say that we want to return env parentheses semicolon. So right now we're referring to our .env file. So inside the parentheses, let's add a set of single quotes. And what we could do right here is to write down our environment variable. So let's say db_database. Now let's save it. Let's go open a new view. Let's go to first project.test. And you can see that our database name has been printed out on the screen. Now let's return to Visual Studio Code. What I want to do is to do it one more time, but instead of using a variable that is already defined for us, let's create our own. So let's open the env file again, and right above app name, let's write down creator_name is equal to your own name. So let's say Dari. Let's save it. Let's go back to our web.php file, and instead of saying dbName, let's change it to creator_name. Let's save it. Let's hop back to Google Chrome, refresh it, and you can see that our variable that we created has been printed out on the screen. And to be honest, I don't recommend you to use environment variables all the time, but mostly for domain names, URLs, authentication, mail addresses, or service account names. You also may have noticed that there is an env.example file inside our root directory. So let's open it up. Let me close off the marketplace. Let's see what the difference is with the env file. Well, the variable names are all the same, as you can see. And what this .env.example file does is simply an example of what might be in the .env file. So if you delete your env file or make changes that you don't need, you can easily rename the .env.example to .env, and you can get started once again. Or let me give you another example. What if you're working on a large project with multiple colleagues, where you are using Git? Does every single person needs to push the .env file to the master? Well, no, because everyone has his own database credentials, and you want to keep the .env file for yourself. What you could do is to send the example file to the master so you know what key and value pairs you need for the project. There are two pretty important files, which are the composer.json and the composer.log file that we have in our root directory. A couple videos back I've talked about Composer, and I've said that it's a dependency manager for PHP that allows us, the developers, to specify project dependencies. Now, this needs to be done inside the composer.json. If the structure of this file is new to you, no worries, this is a .json file. Let's have a look and see what is happening over here. We have pulled a project in with the name of Laravel. The type is equal to a project. It has a description, so the Laravel framework, and it has keywords. It has a license of MIT, which is a permissive free software license. Well, actually the next part is the most important part of Composer, and that's the requirement part. What you see right here is the vendor name, so PHP, PyDeveloper, Fruitcake, Guzzle HTTP, Laravel, and Laravel. They are all separated with a /. So let's see what's going on over here. Let's open our vendor directory and let's write down or search for Guzzle HTTP. Let's open it. And in here, you can see another Guzzle file. So it's searching for the directory inside the vendor called Guzzle HTTP. So it's requiring this specific file over here. Whatever is in the vendor directory is a library. And Composer makes it easier to keep vendor libraries out of the repo. You might be confused right now, but you'll get a better understanding of it if we move deeper in the course. Let's rewind for 1 second. The libraries that are added right here have weird numbers attached to it. And basically, this is the version control with a specific format. So let's take the version number with 3. The first number stands for the patch, the second number stands for the alpha, and the third number stands for the beta. You could also see that almost every version has a caret right in front of it. And the caret stands for the version range. So as you can see right here, we have version 4.2 with a caret, which is equivalent to, let's say, greater than or equal to 4.2, but the version is less than 5. So if PyDeveloper comes out with a new update and it updates it to 4.3, it's still compatible because it will look for a version that is 4.2 and it's less than 5. Let me undo it. All right. So basically, none of the releases until version 5.0 should break backwards compatibility. All right, right below the require section, you can see a require-dev right here. And these are packages that are not necessary for your project to work. You also don't need to add them in project version. So if we delete anything inside the require, our application will crash. But if we delete something inside the require-dev, we're still able to run our project. The config and the extra options are not very necessary, but the autoload might actually be. Right here. Some libraries that we add require autoload. So if we go to our vendor and we scroll down to a file called autoload, let's open it. And you can see that it's basically requiring our composer. Let's go back to our composer file, where you can see that we're requiring 3 things. We have our app, so basically the entire app directory. We have our database factories, and we have our database seeders. If you want to autoload a specific file or a specific directory, you can easily add it on the line below, and it will always be autoloaded. Now, to be honest, the rest of this stuff is not very important. As you can see in our root directory, there's also a composer.log. I won't go too in depth about it because it's pretty much the same exact thing as the composer JSON file. But the point of the log file is that it basically specifies the exact version that we have installed so they can be reinstalled. If we go back to our .json file, you can see, like I just said, that there is a caret right in front of the version. If we go to our composer log, you can see that there is a V. You can see that the caret has been replaced with a V. So a definite version. If you have any type of issue on the log file, or you want to update some dependencies or libraries you've got, you basically need to go to the terminal. So let's do that. Let's cd into our workspace. So desktop first, workspace, first project. All right. And in here, we need to do a rm-rf space composer.log to remove our composer log file. All right, let's write down ls. And you can see that our composer JSON file is still here, but our composer log file is gone. Now to recreate it, you can perform either composer install, or you could perform composer update. There isn't a right or wrong here, but if you run the composer install, it will check if the composer log exists. If not, it will perform a composer update and create one. If you perform the composer update, it will check the composer JSON file. Then it will determine the last version and it will install it and update the log file. So let's do a composer install. Pause the video because this might take a second. As you can see right here, it's updating the dependencies and it's writing the log file. Let's ls. And right here, you can see that our composer.log file has been generated again. The last thing that I want to show you related to Composer is how we could add libraries into our Composer log file with a single command. If you have ever wondered how you could add APIs like payment methods, authentication, resources, or any type of library, it's through Composer as well. Whether you have worked on a training app or real-life project, most of the time you go to Google. So let's do that. Let's go to Google Chrome. Let's open a new tab. Let's go to google.com. What I want to do right now is to show you how you could quickly, and I mean a lot quicker than the manual installation, is to install Packagist through Composer. The way people usually do it without a framework is, well, going to Google, search for, let's say, Molly API PHP. Let's open the GitHub repository. If we scroll down to the installation process, you can see that we have a Composer installation right here and a manual installation part, which is basically saying that we need to download it and include the vendor/autoload. That's not what I want to do. What I want to do is to add it through Composer. This can be done by copying and pasting the command right here. But what I would like to do is to show you a pretty cool website. Instead of using the GitHub, let's go to Packagist. Let's click on packagist.org. You can see Packagist as the main Composer package repository. You can easily search for packages and use Composer to manage your projects or libraries. Right here, you can see a button Browse. Let's click on it. Where you could, well, browse to all the packages that are available, and there are a lot of packages available. What I want to do is to search for Molly. It's the second option created by Molly/Molly API PHP. Right here, you can see a Composer, so let's copy it. Let's go back to our terminal and paste it right inside our first project directory. Let's hit enter, and you can see that it's pulling in all the necessary libraries for Molly. When the installation is done, you can see that it has been pulled in. So what we could do is to go back to our Visual Studio Code, and in our vendor directory, let's search for Molly. So right here. And inside the Composer log, let's Command F and let's search for Molly. Alright then, you can see that a package with the name Molly/Molly API PHP with a version of 2.24 has been pulled in from this specific GitHub repository. And the last thing I want to say is that sometimes when I do this, it won't import the libraries immediately. Whenever I have that, I basically go to the terminal and I write down Composer update to update the dependencies. But usually it works when you install a library through Composer. Like I said in the last video, if we delete anything inside our vendor, we could get it back very easy because we are requiring that specific file inside our Composer log. So let's remove Molly inside our vendor directory. Alright. By doing that, we cannot use Molly anymore because it does not exist in the vendor directory. If we go back to iTerm and run a Composer update one more time, this might take a second. Alright, let's hop to Visual Studio Code, where you can see that Molly has been added once again. We've touched on the vendor directory a little bit in the previous videos, and specifically on the autoload file that's inside our vendor, right here. What this auto file does is basically including the Composer dependencies. And by now, we all know that Laravel uses a lot of libraries that are required through Composer. So it's good to realize that the core framework of our Laravel application is located inside the vendor directory. That also means that if we somehow mess the file up or delete it, we can't run our Laravel project anymore, which I also said in the last video. If we take a look at our vendor directory, you find a lot of folders inside of it which you probably never seen before or heard of. These are all features that Laravel automatically pulls in for us. So it's not that you need to add them whenever you need them, but they are already here when we need it. If we hop back to our terminal, we can perform a command called composer show -- tree. Alright, right here you can see the dependency tree of our project within version numbers. So let me scroll up, because this is quite a lot, as you could see. Alright, take your time and see what kind of dependencies are in here. And well, you might see a lot of Symfony dependencies and you might think, well, isn't Symfony a framework of itself? And yes, you are partially right. Laravel uses a lot of third-party libraries which are mostly Symfony components. And to be precise, 30% of the code inside our Laravel project comes from Symfony itself. Before we wrap up this part of the course, I would like to show you the composer dump autoload. And this command won't download anything, but it regenerates the list of all classes that needs to be included in the autoload. So let's click on enter. Oh, my bad, we need to add a dash. So it's dump dash autoload. And you can see that it's generating optimized autoload files. As you can see right here, these are the files that are required in our requirement. Let's go back to Visual Studio Code. Let's open our composer JSON right here. Alright, that was it. So if the Laravel vendor folder is missing or you're getting an error, you just need to run composer install and everything should work fine.